Nice to see you again. Let's move on to the next 20 questions. Question 61. In the transformer architecture, what is the primary purpose of positional encoding? A. To capture the semantic meaning of each word in the vocabulary. B. To calculate the contextual importance of each word relative to others in the sequence. C. To provide the model with information about the order and position of tokens in a sequence. D. To apply a final nonlinear transformation to the output of the attention block. Okay, this question is about the transformer architecture, which is the foundation for most modern large language models. Our core task is to identify the main purpose of the positional encoding component. It's important to understand what problem this component was designed to solve within the architecture. Let's go through the options. Option A is to capture the semantic meaning of each word in the vocabulary. This is incorrect. This function is performed by word embeddings. They represent the meaning of a word, not its position in a specific sentence. Option B is to calculate the contextual importance of each word relative to others in the sequence. This is also incorrect. This is the function of the self-attention mechanism. Option D is to apply a final nonlinear transformation to the output of the attention block. This is incorrect. This is the role of the feedforward network, which is another component inside a transformer block. This leaves us with option C, to provide the model with information about the order and position of tokens in a sequence. This is the correct answer. The transformer's self-attention mechanism processes all words in a sentence at the same time, so it has no natural way of knowing their order. Positional encoding was created to solve this exact problem. It is a vector that is added to each word's embedding vector to tell the model where that word is located in the sentence. This helps the model understand grammar and meaning that depend on word order. Question 62. While the Word2Vec model is used to learn vector representations for individual words, the Doc2Vec model is an extension of this technique. What is the primary purpose of Doc2Vec? A. To generate a numerical vector representation for each individual word in the vocabulary. B. To classify a document into predefined categories like sports or politics. C. To generate a single numerical vector that represents the semantic meaning of an entire document or paragraph. D. To create a new, synthetically generated document that is stylistically similar to the input. Okay, this question is about comparing two closely related embedding techniques, Word2Vec and Doc2Vec. Our core task is to identify the main purpose and the output of the Doc2Vec model. Let's go through the options. Option A is to generate a numerical vector representation for each individual word in the vocabulary. This is incorrect. This is the definition of the Word2Vec model, which the question is contrasting with Doc2Vec. Option B is to classify a document into predefined categories like sports or politics. This is incorrect. This describes the task of text classification. While the vectors created by Doc2Vec can be used as input for a classification model, Doc2Vec itself does not perform the classification. Option D is to create a new, synthetically generated document that is stylistically similar to the input. This is also incorrect. This is a description of a generative model like GPT or a GAN, not Doc2Vec. This leaves us with option C, to generate a single numerical vector that represents the semantic meaning of an entire document or paragraph. This is the correct answer. This is the exact purpose of Doc2Vec. It extends the idea of Word2Vec by learning an additional single vector for each document or paragraph. This vector, often called a paragraph vector, is designed to capture the overall topic, context, or semantic meaning of the entire block of text, rather than just the meaning of individual words. Question 63. Which of the following options correctly lists the steps of a typical machine learning workflow in the proper sequential order? A. Model training, model evaluation, data collection, data preprocessing, model deployment. B. Data collection, model deployment, data preprocessing, model training, model evaluation. C. Data collection, data preprocessing, model training, model evaluation, model deployment. D. Data preprocessing, data collection, model training, model deployment, model evaluation. Okay, this question is about the standard end-to-end development lifecycle of a machine learning project. Our core task is to identify the correct sequential order of the main steps in this workflow. Let's go through the options. Option A lists the order as model training, model evaluation, data collection, data preprocessing, model deployment. This is incorrect. This order is illogical. You cannot train or evaluate a model before you have collected the data. Option B lists the order as data collection, model deployment, data preprocessing, model training, model evaluation. This is also incorrect. This order is illogical as well. You cannot deploy a model before it has been trained. Option D lists the order as data preprocessing, data collection, model training, model deployment, model evaluation. This is incorrect. You must first have the data, which is data collection, before you can process it, which is data preprocessing. The first two steps in this option are reversed. This leaves us with option C, data collection, data preprocessing, model training, model evaluation, model deployment. This is the correct answer. This represents the most logical and standard workflow in a machine learning project. 1. First, you collect the raw data. 2. Then, that raw data must be cleaned, processed, and transformed into a suitable format. 3. Next, you use the processed data to train a model. 4. After that, you evaluate the performance of the trained model on a separate dataset. 5. Finally, if the model performs well enough, it is deployed into a production environment. Question 64. In the process of training a neural network, what is the primary role of the backpropagation algorithm? A. To perform the initial forward pass of data through the network to generate an output. B. To introduce nonlinearity into a neuron's output. C. To randomly deactivate a portion of neurons during training to prevent overfitting. D. To calculate the gradient of the loss function with respect to each weight, enabling the network to learn. Okay, this question is about the training stage of a neural network. Our core task is to identify the primary and most fundamental function of the backpropagation algorithm. Let's go through the options. Option A says to perform the initial forward pass of data through the network to generate an output. This is incorrect. This describes the forward pass. Backpropagation is the backward pass, which happens after the forward pass is complete and the error has been calculated. Option B says to introduce nonlinearity into a neuron's output. This is also incorrect. This is the role of activation functions like ReLU or sigmoid. Option C says to randomly deactivate a portion of neurons during training to prevent overfitting. This is incorrect. This is the definition of the regularization technique known as dropout. This leaves us with option D, to calculate the gradient of the loss function with respect to each weight, enabling the network to learn. This is the correct answer. This is the core role of backpropagation. After calculating the error between the model's prediction and the actual value, backpropagation sends that error signal backward through the network. It uses the chain rule from calculus to efficiently calculate the gradient, which is the amount that each weight contributed to the error. These gradients are then used by an optimizer to update the weights in a way that will reduce the error, which is the process of learning. Question 65. What is the primary purpose of a generative adversarial network, GAN? A. To classify input data into one of several predefined categories. B. To generate new, synthetic data samples that mimic a real dataset. C. To predict a continuous numerical value based on a set of input features. D. To group unlabeled data points into clusters based on their similarity. Okay, this question asks us to identify the basic function of a famous deep learning architecture, the Generative Adversarial Network, or GAN. Our core task is to understand what GANs were created to do and to distinguish this from other machine learning tasks like classification, regression, and clustering. Let's go through the options. Option A is to classify input data into one of several predefined categories. This is incorrect. This describes the task of classification. Although one part of a GAN, the discriminator, performs a task that is similar to classification, the overall purpose of the entire network is not to classify external data. Option C is to predict a continuous numerical value based on a set of input features. This is incorrect. This describes the task of regression. Option D is to group unlabeled data points into clusters based on their similarity. This is also incorrect. This describes the task of clustering, which is a form of unsupervised learning. This leaves us with option B, to generate new, synthetic data samples that mimic a real dataset. This is the correct answer. This is the exact definition and main purpose of a GENL. It consists of two neural networks, a generator and a discriminator, that compete with each other. The generator tries to create fake data like images of faces that looks more and more real, while the discriminator tries to tell the difference between the real data and the fake data. This process forces the generator to learn how to create new, original, and very realistic data samples. Question 66. How does an autoregressive language model, such as a GPT-style model, generate text? It analyzes the entire input text at once, considering both past and future words, to understand context. B. It classifies the entire text into a single category, such as positive or negative. C. It generates the next token in a sequence based only on the sequence of tokens that it has generated in previous steps. D. It groups similar documents together into clusters without using any labels. Okay, this question is about the working mechanism of a very common type of language model, the autoregressive model. Our core task is to identify how an autoregressive model creates text. The name autoregressive itself is a big clue, as it means it predicts the future based on its own past outputs. Let's go through the options. Option A says it analyzes the entire input text at once, considering both past and future words, to understand context. This is incorrect. This describes a bidirectional or autoencoding model, like BERT. These models are excellent for language understanding tasks, but this is not how generative models like GPT work. Option B says it classifies the entire text into a single category, such as positive or negative. This is incorrect. This is a description of the text classification task. Option D says it groups similar documents together into clusters without using any labels. This is also incorrect. This describes the task of clustering, which is a form of unsupervised learning. This leaves us with option C. It generates the next token in a sequence based only on the sequence of tokens that it has generated in previous steps. This is the correct answer. This is the exact definition of an autoregressive model. It works sequentially. To generate the nth word, it looks at all the words from 1 to n1 that it has already written. This process repeats over and over, generating text one token at a time, from left to right. Question 67. What is the primary application of the t-SNE, t-distributed stochastic neighbor embedding algorithm in data science? A. To train a model to classify data into predefined categories. B. To normalize the scale of features in a dataset before model training. C. To generate new synthetic data samples that are similar to a real dataset. D. To visualize high-dimensional data in a low-dimensional space, such as 2D or 3D, to reveal underlying structures and clusters. Okay, this question is about data analysis and exploration. Our core task is to identify the main purpose of the t-SNE algorithm. Let's go through the options. Option A is to train a model to classify data into predefined categories. This is incorrect. This is a description of the task of classification. t-SNE is a tool for data exploration, not a classification model itself. Option B is to normalize the scale of features in a dataset before model training. This is incorrect. This describes data preprocessing techniques like standardization or normalization. Option C is to generate new synthetic data samples that are similar to a real dataset. This is also incorrect. This is the function of generative models like GANs or diffusion models. This leaves us with option D, to visualize high-dimensional data in a low-dimensional space, such as 2D or 3D, to reveal underlying structures and clusters. This is the correct answer. This is the exact primary purpose of t-SNE. It's a very powerful dimensionality reduction technique that is optimized for visualization. It takes data with many dimensions, which is hard for humans to picture, and projects it down into a 2D or 3D space. It does this in a way that ensures data points that are close together in the original high-dimensional space are also close together in the new low-dimensional space. This makes it excellent at revealing hidden clusters and structures within the data. Question 68. In the context of evaluating the trustworthiness of an AI model, what is the key difference between reliability and validity? A. Reliability measures if the model produces consistent results, while validity measures if the model is actually correct and measures what it intends to. B. Reliability measures the model's accuracy on the training data, while validity measures its accuracy on the test data. C. Reliability refers to the model's inference speed, while validity refers to its memory usage. D. Both terms mean the same thing and can be used interchangeably to describe a model's overall accuracy. Okay, this question is about evaluating the trustworthiness of an AI model. Our core task is to clearly distinguish between the meanings of two important but often confused terms, reliability and validity. Let's go through the options. Option B is that reliability measures the model's accuracy on the training data, while validity measures its accuracy on the test data. This is incorrect. Both of these concepts are different from simply measuring accuracy on different datasets. Validity is closer to the idea of real-world accuracy, but this definition doesn't capture the meaning of reliability, which is about consistency. Option C says reliability refers to the model's inference speed, while validity refers to its memory usage. This is incorrect. Speed and memory usage are performance metrics, not the definitions of reliability or validity. Option D says both terms mean the same thing and can be used interchangeably to describe a model's overall accuracy. This is also incorrect. They are two distinct concepts with different meanings and cannot be used interchangeably. A truly trustworthy model needs to be both reliable and valid. This leaves us with option A. Reliability measures if the model produces consistent results, while validity measures if the model is actually correct and measures what it intends to. This is the correct answer. This is the core difference between the two. Reliability is all about consistency. A reliable model will give you the same or a very similar result every time you give it the same input. This doesn't mean the result is right, just that it's stable. Validity, on the other hand, is about correctness and purpose. A valid model is one that actually predicts or measures what it was designed to do correctly. A model can be very reliable but not valid if, for example, it consistently gives the same wrong answer. Question 69. In a deep learning workflow, data is often loaded and preprocessed on the CPU and then transferred to the GPU for training. When this data transfer becomes a bottleneck, which memory optimization technique can significantly improve the throughput between the CPU and GPU? A. Using a larger batch size. B. Applying data augmentation. C. Using pinned memory, page-locked memory. D. Increasing the number of layers in the neural network. Okay, this question is about performance optimization in a deep learning pipeline. Specifically, it's about the bottleneck that can happen when transferring data from the CPU to the GPU. Our core task is to identify the memory management technique that helps speed up this data transfer. Let's go through the options. Option A is using a larger batch size. This is incorrect. While increasing the batch size can improve the computational efficiency on the GPU by taking advantage of its parallel processing power, it doesn't directly solve the issue of data transfer speed. In fact, a larger batch means more data needs to be transferred, which could make the problem worse if bandwidth is the limiting factor. Option B is applying data augmentation. This is incorrect. Data augmentation is a technique used to create additional training samples, which helps a model generalize better. It is not related to optimizing the speed of data transfer. Option D is increasing the number of layers in the neural network. This is also incorrect. Increasing the number of layers makes the model more complex and requires more computation. It does nothing to help with data transfer. This leaves us with option C, using pinned memory or page-locked memory. This is the correct answer. By default, memory allocated on the CPU is pageable, which means the operating system can move it. Before data in pageable memory can be sent to the GPU, it first has to be copied to a special staging area called pinned memory. By directly allocating your data into pinned memory in the first place, you eliminate this extra intermediate copy step. This allows for a much faster, direct data transfer and can significantly increase the data bandwidth between the CPU and the GPU. Question 70. What is a key shared characteristic between the XGBoost library and the NVIDIA Rapids CUML library? A. Both are designed exclusively for deep learning and neural network tasks. B. Both are primarily used for unsupervised learning tasks like clustering. C. Both can be significantly accelerated using NVIDIA PUS. D. Both are core components of the Apache Spark ecosystem for distributed computing. Okay, this question is about comparing two powerful machine learning libraries, XGBoost and CUML. Our core task is to identify the important characteristic that these two libraries have in common. Let's go through the options. Option A says both are designed exclusively for deep learning and neural network tasks. This is incorrect. Both XGBoost and CUML focus on traditional machine learning algorithms like gradient boosting, linear regression, and SVM, not deep learning. Option B says both are primarily used for unsupervised learning tasks like clustering. This is also incorrect. Both libraries offer a wide range of algorithms for both supervised learning, like classification and regression, and unsupervised learning. They are not limited to just clustering. Option D says both are core components of the Apache Spark ecosystem for distributed computing. This is incorrect. CUML is part of the NVIDIA Rapids ecosystem. While there are versions of XGBoost that can run on Spark, it is not a core component of that ecosystem. This leaves us with option C. Both can be significantly accelerated using NVIDIA PUS. This is the correct answer. This is the most important characteristic they share. CUML, as part of Rapids, was built from the ground up to run machine learning algorithms on PUS. XGBoost, while it can run on CPUs, also has a highly optimized version that takes advantage of the parallel computing power of NVIDIA PUS, which can speed up training time dramatically. Question 71. A user asks a large language model, "Who was the first person to walk on Mars?" The model confidently responds, "The first person to walk on Mars was astronaut Mark Watney in 2035. Even though this event has not happened and the character is from a science fiction novel. What is the correct term for this phenomenon, where an AI model generates a factually incorrect or nonsensical statement but presents it as if it were true? Overfitting. B. Bias. C. Hallucination. D. Quantization error. Okay, this question is about a situation where a large language model creates a piece of information that is factually wrong, but it says it with a lot of confidence and fluency. Our core task is to identify the correct term for this phenomenon, where an AI seems to make up information that isn't true or isn't based on its data. Let's go through the options. Option A is overfitting. This is incorrect. Overfitting is a problem that happens during training, where a model learns the training data too well and then performs poorly on new, unseen data. It doesn't specifically describe the act of creating false information. Option B is bias. This is also incorrect. In AI, bias refers to a model producing systematically unfair results that reflect the prejudices present in its training data. While bias can lead to incorrect answers, the term hallucination is more specific to the act of creating non-factual information. Option D is quantization error. This is incorrect. Quantization error is the small loss of accuracy that happens when a model is optimized by reducing the numerical precision of its weights. It is not related to the model generating fictional events. This leaves us with option C, hallucination. This is the correct answer. This is the exact term used to describe this behavior. An AI hallucination happens when a generative model creates an output that sounds plausible and is well-structured, but is completely false or cannot be verified with real-world facts. It's as if the model is imagining or making up the information. Question 72. From the following list, select two models or techniques that are used to create numerical vector representations, embeddings, of text. Choose two. K-means clustering. B. BERT. C. Backpropagation. D. Doc2Vec. E. A standard convolutional neural network, CNN. Okay, this question is about text embedding, which is a fundamental step in many NLP tasks. Our core task is to identify two models or techniques whose main job is to convert text into meaningful numerical vectors. We need to choose two correct answers. Let's start with the incorrect options. Option A is K-means clustering. This is incorrect. K-means is an unsupervised learning algorithm that is used to group data into clusters. It is not used to create vector representations of text. Option C is backpropagation. This is also incorrect. Backpropagation is the algorithm used to train neural networks. It is not an embedding model itself. Option E is a standard convolutional neural network, or CNN. This is incorrect. CNNs are primarily used for computer vision tasks. While some variations of CNNs can be applied to text classification, it is not a foundational text embedding model in the same way as BERT or Doc2Vec. Now for the correct answers. Option B is BERT. This is a correct answer. BERT, which stands for Bidirectional Encoder Representations from Transformers, is a powerful model that is famous for its ability to create high-quality, contextualized embeddings. It can generate vector representations for individual words or for entire sentences, capturing nuanced meaning from the surrounding text. Option D is Doc2Vec. This is also a correct answer. Doc2Vec is an extension of the word 2-vec technique and is specifically designed to learn and generate a single vector that represents an entire paragraph or document. This vector aims to capture the topic and overall meaning of that whole block of text. Question 73. A company is developing a new AI feature that requires personal user data for training. To adhere to the principle of privacy in trustworthy AI, what is a fundamental practice the company must implement? A. Collect as much user data as possible to maximize model accuracy. B. Use the data for training without explicitly informing users to speed up development. C. Provide users with clear information and the ability to consent to or opt out of their data being used. D. Switch to a more complex model architecture to automatically handle privacy. Okay, this question is about training an AI model using personal user data. Our core task is to identify which action respects the principle of privacy, which is a key pillar of trustworthy AI. Let's go through the options. Option A says to collect as much user data as possible to maximize model accuracy. This is incorrect. This action goes against the principle of data minimization, which is an important aspect of privacy. Organizations should only collect the data that is absolutely necessary for the stated purpose. Option B says to use the data for training without explicitly informing users to speed up development. This is incorrect. This is a serious violation of privacy and regulations like GDPR. Transparency and user consent are mandatory. Option D says to switch to a more complex model architecture to automatically handle privacy. This is also incorrect. The model's architecture does not automatically solve privacy issues related to data collection. While there are techniques like differential privacy that can be built into a model, they do not replace the fundamental need for user consent. This leaves us with option C. Provide users with clear information and the ability to consent to or opt out of their data being used. This is the correct answer. This is the foundation of ethical data handling and respect for privacy. To build trust, companies must be transparent about how they collect and use data, and they must give users control over their own data. This includes the right to give consent, which is to opt in, or to refuse, which is to opt out. Question 74. A developer needs a comprehensive framework to customize a large language model. Their requirements include experimenting with various techniques, from simple prompt engineering to more advanced methods like parameter-efficient fine-tuning, PEFT, and full fine-tuning, which NVIDIA framework provides an end-to-end platform that supports all these model customization techniques. NVIDIA Triton Inference Server. B. NVIDIA DGX System. C. NVIDIA Tensort. D. NVIDIA NeMo Framework. Okay, this question is about customizing a large language model using a variety of different methods. Our core task is to identify which NVIDIA framework is a comprehensive, end-to-end platform that supports a full range of customization techniques, from simple ones like prompt engineering to more complex ones like PEFT and full fine-tuning. Let's go through the options. Option A is NVIDIA Triton Inference Server. This is incorrect. Triton is an inference server that is used to deploy models after they have already been customized. It is not the tool used to perform the customization. Option B is NVIDIA DGX system. This is also incorrect. A DGX system is the hardware, an AI-optimized server. It's the platform that you would run a framework like NeMo on, but it is not the framework itself. Option C is NVIDIA TensorRT. This is incorrect. TensorRT is an SDK used to optimize a model to make it run faster during inference. It is not used for training or fine-tuning. This leaves us with option D, NVIDIA NeMo Framework. This is the correct answer. NVIDIA NeMo is an end-to-end framework designed for building, customizing, and deploying conversational AI models. It provides the tools and APIs for the entire range of methods listed in the question. From experimenting with prompts, which is prompt engineering, to parameter-efficient fine-tuning methods like LoRa, all the way to full fine-tuning. Question 75. In the context of AI governance and developing trustworthy systems, what does certification refer to? A. The process of training the AI model on a large, diverse dataset. B. An informal code review conducted by the internal development team. C. The formal process of verifying that an AI system meets established standards for aspects like security, fairness, and reliability. D. The process of optimizing the model's code for faster inference speed. Okay, this question is about AI governance and building trustworthy AI systems. Our core task is to identify the correct definition of the term certification in the context of AI development. Let's go through the options. Option A is the process of training the AI model on a large, diverse dataset. This is incorrect. This is a description of the training phase, which is a technical step in building a model. Option B is an informal code review conducted by the internal development team. This is incorrect. While a code review is a good practice, certification is a formal, structured process that usually involves an evaluation against external standards, not just an informal internal check. Option D is the process of optimizing the model's code for faster inference speed. This is also incorrect. This is a description of performance optimization, for example, using a tool like TensorRT. This leaves us with option C, the formal process of verifying that an AI system meets established standards for aspects like security, fairness, and reliability. This is the correct answer. This is the exact meaning of certification. It is a formal evaluation process, often carried out by an independent third party, to confirm that an AI system adheres to laws, regulations, and industry standards, like ISO or GDPR, regarding important aspects such as security, privacy, fairness, and reliability. Achieving a certification is a way to formally demonstrate the trustworthiness of a system. Question 76. An inference server is receiving a high volume of individual, real-time requests from multiple users. To maximize GPU utilization and overall throughput, the server automatically groups these incoming requests together into larger batches before processing them, without requiring the client applications to perform any batching themselves. What is this key feature of the NVIDIA Triton Inference Server called? Model fine-tuning. B. Dynamic batching. C. Load balancing. D. Post-training quantization. Okay, this question is about optimizing the performance of an inference server that is receiving a lot of individual requests. Our core task is to identify the correct name for the feature in NVIDIA Triton that automatically groups these individual requests into a larger batch to process them more efficiently on a GPU. Let's go through the options. Option A is model fine-tuning. This is incorrect. Fine-tuning is a training process used to customize a model. It is not a feature of an inference server. Option C is load balancing. This is incorrect. Load balancing is a system architecture technique that is used to distribute requests to multiple different servers. Dynamic batching is an optimization feature that happens inside a single Triton server. Option D is post-training quantization. This is also incorrect. Quantization is a model optimization technique used to make a model run faster. While you can deploy a quantized model on Triton, quantization itself is not a feature of the Triton server. This leaves us with option B, dynamic batching. This is the correct answer. This is the exact definition of dynamic batching. Triton will wait for a very short, configurable amount of time to collect individual inference requests and will automatically combine them into a larger batch. Processing a single large batch is much more efficient and makes better use of the GPU's parallel processing capabilities than processing many small, individual requests. This results in a significant increase in throughput, which is the number of requests that can be processed per second. Question 77. According to the concept of scaling laws in deep learning, what is one of the most reliable ways to predictably improve the performance of a large language model? A. Changing the activation function from ReLU to sigmoid. B. Increasing the size of the training dataset and the number of model parameters. C. Applying post-training quantization to the model. D. Switching to a different optimization algorithm like from ADAM to SGD. Okay, this question is about improving the performance of a deep learning model, specifically a large language model. Our core task is to understand the concept of scaling laws, which describe the predictable relationship between a model's scale and its performance. Let's go through the options. Option A is changing the activation function from ReLU to sigmoid. This is incorrect. While the choice of activation function does impact performance, this is a small microarchitectural change. Scaling laws refer to larger scale factors, and changing from ReLU to sigmoid would often decrease performance in deep networks due to the vanishing gradient problem. Option C is applying post-training quantization to the model. This is incorrect. Quantization is an optimization technique used to speed up inference. It usually slightly decreases a model's predictive accuracy, so it is not a method for improving performance. Option D is switching to a different optimization algorithm, like from ADAM to SGD. This is also incorrect. The choice of an optimizer is important, but it is not the scale factor that is referred to in scaling laws. Both ADAM and SGD are used to train large models, and the scaling laws still apply regardless of which optimizer you choose. This leaves us with option B, increasing the size of the training dataset and the number of model parameters. This is the correct answer. This is the core principle of scaling laws. Research has shown that the performance of large models, as measured by their loss, improves in a predictable power-law relationship when we increase three things: the model size, which is the number of parameters, the size of the dataset, and the amount of computing power used for training. Question 78. Which of the following statements best describes the primary roles of ONNX and NVIDIA TensorRT in a machine learning workflow? A. ONNX is used to train neural networks while TensorRT is used to collect and pre-process data. B. ONNX is an open format for model interoperability, while TensorRT is an SDK for optimizing and deploying models for high-performance inference. C. Both ONNX and TensorRT are used for the same purpose of training models from scratch. D. ONNX is an SDK for optimizing model performance, while TensorRT is an open format for model interoperability. Okay, this question is about the machine learning deployment workflow and involves two important technologies. Our core task is to correctly identify and distinguish between the functions of ONNX and NVIDIA TensorRT. Let's go through the options. Option A says ONNX is used to train neural networks, while TensorRT is used to collect and pre-process data. This is incorrect. Both of these descriptions are wrong. ONNX is not a training framework and TensorRT is not a data processing tool. Option C says both ONNX and TensorRT are used for the same purpose of training models from scratch. This is also incorrect. Neither of these are tools for training models from scratch. They are both used in the stages after a model has already been trained. Option D says ONNX is an SDK for optimizing model performance, while TensorRT is an open format for model interoperability. This is incorrect because it has the roles of the two technologies reversed. This leaves us with option B. ONNX is an open format for model interoperability, while TensorRT is an SDK for optimizing and deploying models for high-performance inference. This is the correct answer. This statement accurately describes the role of both. ONNX, which stands for Open Neural Network Exchange, acts as a universal translator. It's a standard file format that lets you move a model that was trained in one framework, like PyTorch, to another framework without having to retrain it. TensorRT is a toolkit that you use to take a trained model, often in the ONNX format, and optimize it to run inference extremely fast on NVIDIA PUS. Question 79. Which of the following are two primary benefits of applying model quantization to a trained deep learning model? Choose 2. Increased inference throughput. B. Significantly improved predictive accuracy. C. Reduced model memory requirements. D. Simplified data collection process. E. Reduced model training time. Okay, this question is about optimizing a deep learning model that has already been trained. Our core task is to identify the two main benefits of applying the model quantization technique. Let's start with the incorrect options. Option B says significantly improved predictive accuracy. This is incorrect. Quantization usually involves a small trade-off in accuracy. The goal is to keep this decrease in accuracy as minimal as possible while gaining the performance benefits. Option D says simplified data collection process. This is incorrect. Quantization is a model optimization technique and is not related to the data collection process. Option E says reduced model training time. This is also incorrect. The main benefits of quantization, especially post-training quantization, are seen in the inference stage, not the training stage. Now for the correct answers. Option A is increased inference throughput. This is a correct answer. Throughput is the number of requests a model can handle in a given amount of time. Because integer math operations execute much faster than floating point operations on modern hardware, a quantized model can make predictions more quickly, which therefore increases its overall throughput. Option C is reduced model memory requirements. This is also a correct answer. By using lower precision data types, like int8 instead of FP32, each parameter in the model takes up less space. This significantly reduces the model's file size and the amount of memory, like RAM or VRAM, needed to run it. Question 80. A team of researchers has developed a new neural network model for translating text from English to Japanese. To gauge the quality of the generated translations, they need to compare them against several high-quality translations created by human experts. Which of the following metrics is the industry standard for this task? Accuracy. B. Mean absolute error, MEA. C. Blue bilingual evaluation understudy, score. D. Perplexity. Okay, this question is about evaluating the quality of a machine translation model. Our core task is to identify the standard metric that is used to compare a translation generated by a machine with one or more sample translations created by humans. Let's go through the options. Option A is accuracy. This is incorrect. Accuracy is a metric for classification problems used to calculate the percentage of correct predictions out of the total number of predictions. It is not suitable for evaluating the quality of a translated sentence. Option B is mean absolute error, or MEA. This is incorrect. MEA is a metric for regression problems used to measure the average difference between a predicted value and an actual value. Option D is perplexity. This is also incorrect. Perplexity is a metric used to evaluate the intrinsic quality of a language model itself, for example, its ability to predict the next word. It is not used to evaluate the quality of a specific task like translation. This leaves us with option C, blue score, which stands for bilingual evaluation understudy. This is the correct answer. Blue is the most widely used metric for evaluating machine translation models. It works by measuring the overlap of n-grams, or phrases of n words, between the machine's translation and the human reference translations. A higher blue score indicates that the machine's translation is of better quality. Thanks for watching. If you found this video interesting and helpful, please like, share, and subscribe to our channel. See you in the next video. Happy learning!